Okay, so here is quiz number 3. First question, use transformations of the graph to graph that. So what is that going to look like? So x to the 5th, anything with an odd power is a snake graph. We can see these are all snake graphs. How do we know which one is right? I'm going to suggest the make a table plan. To find the center, remember what you plug in? You plug in right there for x, what will make the x zone, this little part, 0. So that would be 3. Plug that in, y is going to equal 1 minus 3 minus 3 to the 5th, which is 1 minus 0, which is 1. So that means over 3, let me graph it right here, over 3, up 1, that's the center of the snake graph. Now what do you do for another point? Add 1. So add 1 to that, 4. Plug in 4. What are you going to get? 1 minus 4 minus 3 to the 5th, which is 1 minus 1 to the 5th, which is 1 minus 1, which is 0. So over 4, up 0. So this is the center point, and this is the other point. So that means the snake must be doing something like this. This is the center. This is the other point, 4, 0. This is the center, 3, 1. So which one looks like that? Goes down to the right. This one goes down to the right. Oh, but it's over on the left side. This one goes, so it's not A. This one goes down to the right, but it looks like the center's 4. Oh, yeah, it does. It has 3, 1 is the center. It has the point 4, 0. There it is. Answer B. Question 2, determine whether the graph could be the graph of a polynomial. If it could be, list the real zeros and state the least degree the polynomial can have. Yeah, that's certainly a polynomial graph, just smooth curve, goes up and down, smooth curve. What are the zeros? What do they mean by the zeros? The real zeros. Those are the x-intercepts. The places where the graph is at a height of 0. That's what a 0 is. So that'd be here, here, and here. At those places, the graph is at a height of 0. That's it. X is -1, +1, and what's that? +4. At all those places, the graph has x-intercepts. So that would be -1, regular 1, and 4. Those are those zeros, we call them, height of 0, x-intercepts. So that's that answer. And then, isn't there another question? And state, and the least degree that the polynomial can have. What do they mean, the least degree? Well, remember that the max number of turning points, remember that little formula, the max number of turning points is the degree minus 1. So how many turning points does this graph have? 1, 2. That's a turning point. The graph goes from going up to going down, and here's another TP turning point where it goes from going down to going up. So it's 2 turning points. So the maximum number of turning points, 2, is the degree minus 1. So they're asking, what's the degree? Add 1. Boom. The degree is 3 or more. The degree must be 3. That's why they say it's the least degree. The degree can be 3 or more. If the degree is 3 or more, then it would have 2 turning points maximum. There we go. So here we are with number 3. We're going to graph this function. I'm again going to suggest making a table. So what do we plug in to find the center? This is a snake graph again, 5th power, odd power is a snake graph. You plug in, to find the center, you always plug in what will make, right there, what will make the x zone 0. So that's -1, isn't it? -1, y will equal 7 times -1 plus 1 to the 5th plus 3. That is 7 times 0 to the 5th plus 3. That's 3. So that means back 1 up 3. Right there, at back 1 up 3 is the center dot. That's the center. Now, let's find one other dot. What do we always do? We add 1. So that'd be 0. And so plug in 0 now. What are you going to get? Y equals 7 times 0 plus 1 to the 5th plus 3. That's 7 times 1 to the 5th plus 3. That's 10. So over 0 up 10. It's way up here. 4, 5, 6, 7, 8, 9, 10. Way up here. So this is over 0 up 10. So the graph, here's the center point, and there's that other point. So what does that mean? The graph must go from lower left to upper right, because this is the center, and that's another dot. So which one has that? Going up to the right kind of thing, and the center is minus 1, 3. This one, minus 1, 3, 0, 10. The answer is C. Okay, graph problem number 4. Going to graph it. Again, they want us to find the graph, so I'm going to make a table. And remember how we do this. I'm going to plug in the center. How do you find the center? You plug in whatever will make the x zone 0. That would be 2. Plug that in. Y will equal 3 plus 6 over 2 minus 2 squared. That's 3 plus 6 over 0. Now, what do we do with that? That's undefined, really. It is. That's true. But you pretend that that's 0. It's really undefined. So in that case, y would be 3. So that's not going to really be a point on the graph, but it actually will be a helpful point. 1, 2, 1, 2, 3. Right there, the point over 2 up 3. What is that point? Remember, it's the center of the axis. It's the center where the two asymptotes, I should say, cross at over 2 up 3. The two asymptote lines will cross each other. See, it's not a point on the graph. The graph won't actually touch it because it is undefined right there. But we just pretend that's 0, and so y just equals 3. Gives us the center of the crosshairs, so to speak, the center of the two asymptote lines. What do we do now? We need another point. So you know what we do? We add 1. So add 1. This will be 3. Plug in 3. What are you going to get? 3 plus 6 over 3 minus 2 squared. That is 3 plus 6 over 1. That's 9. Over 3 up 9. So over 3 up 3, 4, 5, 6, 7, 8, 9. Way up here. Boom, there's a dot way up here at 3, 9. So what does that mean? That means we have a branch up there. And now where's the other branch? Now this one is squared. So squared means the branches are side by side. So the other one's up here. 2 branches up high. So where's that going to be? Which one of those looks right? Well, the only one with the right crosshairs is D. See how the center of the crosshairs right there is right and up? So that looks right. Okay, so number 5. We're supposed to find the vertical, horizontal, and oblique asymptotes, if any. So the vertical, how do you find vertical? So for vertical asymptotes, it's all about the denominator equaling 0. So grab that denominator and say x to the 4th minus 1 equals 0. Solve that. How do you do it? I'd factor x squared minus 1, x squared plus 1. Factor this, minus 1 plus 1. X squared plus 1 stays the same. Remember how this can't break down anymore? It just stays the same, whereas this guy breaks into these two. Okay, and now, so what can make that part 0? X is 1. What can make that part 0? Negative 1. What can you plug in there to make that 0? Nothing. So the only two vertical asymptotes are 1 and negative 1. Either order on that. Next, we got to do the horizontal or oblique asymptotes. How do we do horizontal or oblique? Remember, it's all about the biggest power on the top and the biggest power on the bottom. So this function, x cubed over x to the 4th minus 1, basically, if you're for horizontal and oblique asymptotes, you're imagining if you plugged in like a million, all that would matter is this over this. The minus 1 would be irrelevant. So it'd be y equals, and then these would cancel to be 1 over x, right? This would go in here, leaving x to the 1. And if you plugged in a million, like infinity, What's 1 over infinity? 0. Y equals 0. 0 is the horizontal. It's a flat asymptote is what that means. Basically, the denominator won the tug-of-war. Bigger power on the bottom than on the top. Flattens the graph down. Okay, we're supposed to find the vertical and all the other asymptotes. Let's try to factor this first. I'm not sure if it will factor. Let's see, 4 to be 20, plus 1 plus 1, minus 1 plus minus 19. Yeah, that's factorization there. Now, if you're not sure on that, if you're rusty on factoring, then you need to practice foiling again and again until you can find out that that is the right factorization. Let's see, for 20, be 4 and 5. You cannot put the 4 with the same as the 2, in the same principle with the 2. So 5 there, 4 there. So that 5 and 8, minus, plus 5, yeah, that's right. Yeah, and look at that, something cancels, doesn't it? Boom, boom. So this just becomes 5x plus 1 over 2x plus 5. So make sure you can factor like that. Check those by foiling. So what's the vertical then? Well, the vertical is the denominator equal to 0. So that's 2x plus 5 equal to 0. Jump the 5 over. It's minus 5 divided by 2. X is negative 5 halves. There's the vertical. How do you find the horizontal? Well, the horizontal is all about plugging in x as infinity. So if you come back, all that's going to matter is the most powerful term in the top and the most powerful term in the bottom. You get 5x squared over 2x squared, which reduces to be 5 halves. Y equals 5 halves. By the way, you might wonder, well, do we have to go back to the beginning? No, if you took it here, it'd be the same thing, right? 5x over 2x, still going to be 5 halves. Either way. What is that? That's 2.5. I think they want a fraction, so we're going to leave that as the answer. But if you're wondering, that's a 2.5. That's at 1, 2, 3, so at 2.5, there's a flat asymptote. That graph eventually will flatten out at 2.5 as you go right forever, because the top and the bottom have a tug-of-war. They tie in power. They cancel, so y equals 5 halves or 2.5. That's the end behavior, the destiny of that function. Okay, number 7. First off, they want the domain. How do we find the domain? Denominator cannot be 0, so grab that denominator. X squared plus x minus 90 can't be 0. So 9 and 10. Plus 10 minus 9, right? Because you got to get plus 1 in the middle. The plus 10 minus 9 can't be 0. So then x cannot be positive 9 or negative 10, right? What'll make that 0 is 9. What'll make that 0 is negative 10. So there's our answers, 9 and negative 10. So B, x cannot equal 9 or negative 10. Next part, what's the vertical asymptote? Well, same stuff. It's those same numbers. 9 and negative 10, which make the denominator 0, are the vertical asymptotes. That's why they're not in the domain, and they make vertical asymptotes. Next question, horizontal or oblique? What's the story with that? Well, remember, it's all about the tug-of-war. Go back to the beginning here. Y equals biggest power in the top, biggest power in the bottom. X squared. Nothing else matters. If you're going way off to the right to like 1,000, a million, and a billion, all that's, and you're going to plug in like 1,000 here and 1,000 here and 1,000 here. This stuff's all small potatoes compared to 1,000 squared, 1,000 thousands, and up here same thing. So that's just 1. Y equals 1. Horizontal asymptote. It's a flat line at a height of 1. Finally, part D. Which is the correct graph? So this would be graph it on your graphing calculator, and what you'll find it's answer A. If you graph it on your graphing calculator, see that horizontal asymptote at a height of 1, and those 2 vertical asymptotes. There it is. Okay, so this function, let me just call it y equals t. If you can tell that's a t over 4t squared plus a. They're asking us to find the horizontal asymptote. Remember how we find horizontal asymptotes? We basically plug in infinity, and it's highest power on the top over highest power on the bottom. So it would be t over 4t squared. That's all that matters. If you're plugging in something like 1,000, if you're going way and 1,000 for t there, all that's going to matter, 8's not going to matter at all. And then what will happen here, this will reduce to be 1 over 4t. So y equals 1, equals 1 over 4t. And then we're plugging in something like 1,000, infinity. 1 over 4 times infinity. That's 1 over infinity, which is 0, right? 1 over infinity is 0. You good with that? That's like 1 over a million. If I said I ate 1/1,000,000th of the pie last night, that's no pie. That's like a crumb. 1/1,000,000th of the pie is 0. So y equals 0, or C. C is my y, right? I called it y, but it's C. C is 0. That means the concentration of the drug in the patient's bloodstream will flatten out to 0 over time. Part B, they want you to graph it on your calculator. You'll find that this graph is right. And then part C, they want you to find highest. That is maximum. So on your graphing calculator, do maximum on your graphing calculator. You'll find T is at 1.41. It'll be the X value, which is the same as the time. It's right there. That's the maximum. Like that. See how it flattens over time? The drug goes down to nothing in your bloodstream over time. So here we are on number 9. So they want the surface area of the box. Well, if you think about it, this box is going to have 6 sides. So the surface area of this box is 6 sides. It's got a bottom and a top. It's got a front and a back. Sorry, I'm being a little scribbly there. Front and a back. It's got a left and a right. So the bottom here is x squared, because that's just one side times the other for the area of a rectangle. The top is the same, right up here, same as the bottom. Just add all these. It's going to add up these 6 sides for the total area of the box, surface area. Then the front, what's the front? Well, this is the front of the box, which is x by y. See the height of the box back here is y, same as here, x by y. And then the reason these are both x, by the way, is because it's a square base. They're the same, but the height is different. We're calling that y. So the front and the back, right? The back here would be exactly the same as the front. It's just x by y. And then what about the right, left side and right side? So the right side here, here's the right side. That's also x by y, isn't it? And the left. Right and the left are both x, y. So there's the surface area formula. So let me bring that down here, clean it up. X squared plus x squared, 2x squared. X, y added up, 1, 2, 3, 4 of them. 4xy. So there's the surface area formula, except they want it only in terms of x. I got to get rid of that y. How in the world am I going to get rid of that y? Well, I need another formula. Remember, you always need a secondary formula on these. What's the other formula? Volume's 11,500. What's the volume of a cube? It's length times width times height, the 3 dimensions. So the volume, which is, what is it, 11,500, is length with height. So it's x by y. X times y is the height. Okay, now what am I going to do with that? I want to solve for y and plug in there. So divide by x squared. Cancels out. So y equals this. Plug that right in there. And so what do you get? You get surface area is 2x squared plus 4x. And what's the y? 11,500 over x squared. That plugs in right there. So now let's clean that up. We can do one more step. 2x squared plus, this is over 1. This x cancels one of those. And 4 times 11,500 was at 46,000, I think, over 1x, because this x canceled one of these guys. So there would be the surface area formula with only x. That's part A. Okay, now they want me to graph it on my calculator. If you graph it on your calculator, you'll find that, and they're telling you the window, 0 by 100 and then 0 by 8,000, and you'll find that D is the right graph. I can show you, there it is. You'll see the D is the right graph. And then they want you to find this minimum value right there. The minimum value. And so, what you'll find, it says, what is the minimum amount of material? And what are the dimensions of the box? And value of X and value of Y. Okay, well, it turns out that you'll find, let me go to X. Whoops. You'll find on your calculator 22.57. This point here, if you do minimum on your graphing calculator, you'll find the X value is 22.57. And the Y value is 30.57. Do you see why I put the Y there and not here? That's probably confusing. Remember, when you graph on your calculator, it'll tell you the point 22.57, comma 30.57 for this dot here, but that's X, comma S. Why? Because we put this in, this is Y1, we just put into our graphing calculator to graph it. So the Y values of this are S values, surface area, material, surface area. Well, then how do you find the actual, like, Y value up here on the box? You have to plug into this little formula here, which I've kind of messed up now. It's 11,500 over, what was it? X squared. X squared, that's what Y equals. You got to take your X, your 2257, plug in right there. So this will equal, bring it down here, it'll be 11,500 over the 22.57 squared, because that's what Y equals. It's 11,500 over X squared. That should come out 22.58.